Welcome to this tutorial on WASSCE 2024 Physics Practical Exams, focusing on the concept of moments. In this video, we will go through each step of the experiment, from setting up the apparatus to accurately taking data, plotting graph, calculating the slope, and highlighting important precautions. By the end, you will have a clear understanding of how to approach this practical with confidence. Let's dive in. You are provided with a hanger of mass 20 gram, a fixed mass labeled X, slotted masses, a meter rule, two loops of string, and a knife edge. Place the meter rule on the knife edge with its scale facing upward. Adjust the position of the knife edge until the meter rule balances horizontally as shown in figure 1a. So we want to balance the meter rule horizontally on the knife edge. The meter rule is now balanced horizontally. Record the point of balance G. The point of balance is 50.1 centimeters. The knife edge is too small for the experiment, so we are going to use the retort stand to balance the meter rule. Use one of the loops of string to attach the 20 gram mass hanger securely at G. G is 50.1 centimeters measured from this direction. So we are going to hang the 20 gram mass at 50.1 centimeters. And do not change the position of the hanger throughout the experiment. Attach the mass X securely at a distance AP is equal to 2 centimeters on the meter rule. So we attach the mass X at 2 centimeters on the meter rule, measuring from this direction. So we have the 20 gram mass at 50.1 centimeters and the mass X at 2 centimeters. The position of X should also be kept constant throughout the experiment. Add a 20-gram slotted mass to the hanger and record the total mass of the hanger and the added mass as M is equal to 40 grams. So we are going to add 20 grams to the hanger. So this is 20 grams plus the mass of the hanger, which is 40 grams. Adjust the position of the knife edge until the rule balances horizontally at Q, as shown in Fig 1b. In this case, we are using the retort stand. So this is the diagram, and we are going to adjust the meter rule to balance horizontally with the 40-gram mass here and the mass X also here. Read and record the distance GQ is equal to D. That is, we want the distance between the balance point and G. So we have 50.1 centimeters minus 37.8 centimeters, and that is the distance between the balance point and G. So 50.1 centimeters minus 37.8 centimeters is 12.3 centimeters. So we have a mass of 40 grams and D is 12.3 centimeters. Evaluate D inverse. So we have D inverse here and the unit will be per centimeters. So we have 1 divided by 12.3 giving us 0.081 per centimeters. And we are going to repeat the experiment for 4 other total mass. M is equal to 60 gram, 80 gram, 100 gram, and 120 gram. In each case, read and record D and evaluate D inverse. So we are going to add 20 gram to the 40 gram mass and balance the meter rule horizontally. We find the distance between G and the balance point. That will be 50.1 centimeters minus 38.9 centimeters, and we have 11.2 centimeters, and that is D. So the mass is now 60 grams and D is 11.2 centimeters. And we evaluate D inverse, that is 1 divided by 11.2, and we have 0.089 per centimeter. We add another 20 grams to the 60 gram mass to make it 80, and find the balance point. And we find the distance between the balance point and G. That will be 50.1 centimeters minus, this is 39.9 centimeters, giving us 10.2 centimeters. So the mass is now 80 grams and D is 10.2 centimeters, and D inverse is 1 divided by 10.2, which is 0.098 per centimeter. We add another 20 grams to make it 100 grams and find another balance point. Okay, so now we have 50.1 minus 40.8 centimeters, which gives 9.3 centimeters. So we have a mass of 100 grams. D is 9.3 centimeters. We find D inverse, that is 1 divided by 9.3, and we have 0.108 per centimeters. We add another 20 grams, making 120 grams. And find a new balance point. And find D. That will be 50.1 centimeters minus 41.5 centimeters, which gives 8.6 centimeters. So we have a mass of 120 grams. D is 8.6. We find D inverse. 1 divided by 8.6 is 0.116 per centimeter. we tabulate the results and plot a graph with M on the vertical axis and D inverse on the horizontal axis, starting both axes from the origin 0, 0. So for the plotted values, we need the values of M. For the values of M, we have 40, 60, 80, 100, and 120 grams. And for the values of D inverse, they are all decimals, and it will be difficult to plot these decimals on the graph accurately. So we are going to change them to standard form. For the first value, we have 0.081 per centimeters. We move this point 1, 2, 3 to the right, and it becomes 81 times 10 exponent negative 3 per centimeters. For the next value 2, we move the point 1, 2, 3, and we have 89. Also times 10 exponent negative 3 per centimeters. It means that when you multiply each value here by 10 exponent negative 3, you get the corresponding value on the tabulation of results. So the next value will be 98, the next one will be 108, and the next one will be 116. So we are going to plot these values on the graph. So we draw the vertical and horizontal axis. And we are plotting M on the vertical axis and D inverse on the horizontal axis. We choose a scale. We are going to choose a scale of 2 centimeters is to 20 gram on M axis. So we start from 0, 20, 40, 60, 80, and so on. And on the horizontal axis, we choose a scale of 2 centimeters is to 20 times 10 exponent negative 3 per centimeters on the D inverse axis. So we start from 0, move to 20, 40, 60, and so on. Each big box has 10 divisions. So here on the vertical axis, 20 divided by 10 is 2. So each small box is equal to 2. And on the horizontal axis too, each small box is equal to 2. For the first point, we have 40 grams on the vertical axis. This is 40. And we have 81 on the horizontal axis. This is 80. One box is 2. So in the middle of the next box, we have the 81. So they will meet here. The next one, we have 60 on the vertical axis. This is 60. 89. This is 80. One box is 2. So 82, 4, 6, 8, and 9 will be in the middle of the next box. The next one, we have 80 on the vertical, 98 on the horizontal axis. The middle here is 90, 92, 4, 6, 8. We put the point here. The next one, we have 100, 100 on the vertical axis, and 108 on the horizontal axis. This is 100, 102, 4, 6, 8. And the next one, we have 120 on the vertical axis. This is 120 on the vertical axis. And we want 116 on the horizontal axis. This is 100, 102, 4, 6, 8, 10, 12, 14, 16. So we draw the line of best fit. Determine the slope S of the graph and the intercept C on the vertical axis. So for the slope, we draw this horizontal and vertical, forming a triangle with a line of best fit. We name here A, here B, and here C. The slope is change in BC over change in AB. For change in BC, we have 162,468 minus 20 gram. For change in AB, we have 140 minus 70. Remember, times 10 exponent negative 3, and the unit on the horizontal axis is per centimeters. And now 168 minus 20 is 148 gram. 140 minus 70 is 70 times 10 exponent negative 3 per centimeters. And 70 times 10 exponent negative 3 is 0.07. And 148 divided by 0.07 is 2114.3. We have gram at the numerator and per centimeters is at the denominator. So the reciprocal of per centimeters is centimeters. And this is the slope. And for the intercept on the horizontal axis, we have 60 times 10 exponent negative 3, and the unit is per centimeters. And 60 times 10 exponent negative 3 is 0.06 per centimeter. If in this experiment m is equal to 70 gram, use the graph to determine the balance length D. So from the graph, if m is equal to 70 gram, 70 will be between 60 and 80. So we draw this line to meet the line of best fit and project it to the horizontal axis. And here we have 80, 82, 4, 6, 8, 90, 92, 94. So we have the inverse to be 94. Remember, times 10 exponent negative 3, and the unit is per centimeters. And 94 times 10 exponent negative 3 is 0.094 per centimeters. But we are looking for D, not D inverse. D inverse is the same as 1 over D. We cross multiply. So we have 0.094 per centimeters times D is equal to 1. and we divide through by 0.094 per centimeters to get our D. And 1 divided by 0.094 is 10.6, and per centimeters is at the denominator. So the reciprocal of per centimeters will give us centimeters. Calculate Z using the equation Z is equal to 100 plus the slope divided by 50. We have Z is equal to 100 plus S over 50, but we know the slope, so we replace it. So we have Z is equal to 100 plus 2114.3 grams centimeter divided by 50. And 100 plus 2114.3, and the result divided by 50 is 44.3, and the unit is gram centimeter.